Hi students, in this video we are going to study about elimination of epsilon production. So all of us know what is elimination. Elimination is nothing but reduction of the grammar. When the grammar is given, we need to simplify the grammar. For simplifying the grammar, we learned three steps. One is elimination of useless symbol, elimination of epsilon production, and elimination of unit production. In the last video, we learnt about elimination of useless symbol. In this video, we are going to learn about elimination of epsilon production. So first, before getting into how do we eliminate epsilon production, first let us learn about what is epsilon production. Production of the form A implies epsilon are called epsilon productions or null productions. When the production of this form A implies epsilon, the right hand side, if epsilon is there, such productions are called epsilon production or null production. So this will not have any terminal or non-terminal. This will have only, this production will have only epsilon. Such productions are called epsilon production or null production. Okay, coming to the next definition, nullable variable. So what is nullable variable? Nullable variable is if A is a variable, A implies epsilon, that is if A leads to an empty string in 0, 1 or more derivations. So for A variable, from A variable I am trying to derive. So when I am trying to derive after 0 or more derivations, if I am getting the empty string, then A becomes a nullable variable. Okay, take this example. S implies A, B, C, A or B, D. A implies B, C or B. B implies B or epsilon. C implies C or epsilon. D implies D. So in the given grammar, you can see B implies epsilon. B implies epsilon. C implies epsilon. This production is called as a epsilon production or nullable variable. You can also call it as a nullable variable. So in this nullable variable, if I am substituting this nullable variable in any production and that production leads to an empty string, then that variable will be called as nullable variable. Take this example. S implies A, B, C, A. Okay. So here A I have, and for B I can substitute epsilon, and C I can substitute epsilon, then A. Then it will become A. So what is A? A also it is given as B. I can substitute B and A. So after this I cannot substitute because I got the terminal string. With this I will stop. I will not be substituting anymore. If non-terminal is there, only for non-terminal I have to substitute. So I got the terminal string. Okay. So in this I am not getting any empty string. I am getting some string. So this is not a nullable variable. So yes, A you are taking. So A implies BC. So what is A implies BC? So what is B? B is epsilon and C is epsilon. Epsilon into epsilon becomes empty string. So now A gives you a empty string. So if A leads to an empty string, then A also will become a nullable variable. Since A does not have epsilon production, but still it is also called epsilon nullable variable. Why it is called a nullable variable? When we are deriving a string 0 or more, I am applying B. For B I am substituting the value, and for C I am substituting the value. After the substitution, A becomes an empty string. Then this A is called as nullable variable. Okay. So now after identifying the nullable variable, then we have to go for the theorem. So there is a theorem to eliminate the epsilon production. We have to apply this theorem and then eliminate the epsilon production. So I will be quickly I will explain the theorem in this video, and next video I will be solving the problem. So you will understand the theorem when it is applied in the problem. So now first step 1 in the theorem, step 1 is construction of a set of nullable variable. So first we need to identify the nullable variable. and then we need to construct a nullable variable. So how do we identify? The steps are given below. The nullable variables nullable variables are called W, can be computed as follows. How are we going to do? Wi. I is nothing but the iteration variable. So I can be 1 and above. So Wi is equal to A such that A is in V and A implies epsilon is in P. So A is a variable. A is a variable. A is in V, and if A has a value as epsilon at the right hand side, that has to be added in Wi. Then Wi plus 1 is equal to Wi. Already you identified the epsilon production that you added in Wi. So now Wi union A such that A is in V and A implies alpha. Alpha can be of terminal or non-terminal. It can be anything. By substituting this value here, this A will lead to a empty string. Such production also will become a nullable variable. So that has to be added in Wi plus 1. So this I have to repeat this two steps until this condition becomes true. That is Wi is equal to Wi plus 1. I have to repeat. So this is the steps to construct the nullable variable. Now step 2. Step 2 is construction of P dash. Now P dash I have to construct. So what are the steps in construction of P dash? Any production whose right hand side, you have to see the production at the right hand side, does not have any nullable variables. If there is no nullable variables, nullable variable you are identifying in step 1. So in step 2 what we are doing, at the right hand side we have to see the production. If the production doesn't have the nullable variables, then it is included in P dash. Such production I have to include in P dash. For every production of the form A implies alpha in P, alpha belongs to W1, add to P dash. Okay, so if alpha A implies alpha, okay, so if you have this form, if nullable variable is not there, then it has to be added to P dash, all the production that can be obtained. Whatever production, the production which is not going to give you the nullable variable, all the production have to be included in P dash. So this is the theorem. So when we apply the theorem in the problem, you will understand better. So in the next video, I will explain about the problem solving using this theorem. Thank you.